Yeah, good morning, good afternoon, good night. I don't know what time you're watching this, so yeah. So it's been a while. I think it's up to a year I made the last videos, and I've been really, really busy. But I think I have some time now, so let's work on this. So we're supposed to make the outcrop map today, and I'm assuming you've gone to the field, so you have your outcrop details. So that's what we're going to be working on today. And yeah, if the video helps you, I'd love it if you can drop a comment. Yeah, so let's go on. Yeah, so when you get to the field, you come back with your longitude data, your latitude data, your bed altitude. Your bed altitude, that's the deep, the strike, and lithofacial details. So we are on Excel here to make a table that you use to input all those into your ArcGIS. Yeah. So yeah, so we'll start with location name. Say location. Yes, after your location name should be your longitude and latitude, but not in the degree minute second that you're used to. It should be in decimal degree. So latitude DD, longitude DD. Then we enter into the bed altitude, so strike, deep direction, deep D, then deep amount, deep A. Then yeah, lithofacial, which is the rock type. This form, you can always make it. I have a form like this already on my laptop, but because I'm showing you, I'm making it again. So yeah, the location, I normally use my initials, Moye Ekene Augustine, so MEA01 down to as much as you can. So for latitude DD, you always know, you've known latitude in mostly degree minute seconds. So what you do is you go online and convert it. Let me show you how to do that. Pretty simple. So yeah, on Google you just search DMS to DD. Pretty simple. Enter this first one. I always use this. So assuming my latitude is 6 degrees 20 minutes 34 seconds, and longitude is 5 degrees 21 55 seconds. When you click convert, it shows you this. All you have to do is copy, paste, paste here, Ctrl V, copy again, copy this, paste here, and you're good to go. And your strike is, of course, your strike has two values, but you could just put any one. I mostly put the up one, so if my strike is say 20, then my deep amount is say 110. I'll still use actual reading. I'm just showing you how to do this. And lithofacial is shale. Here you should be specific with the with the cap lock and all. So I think it's better we just use it in normal, okay, all in cap lock, because when you move into ArcGIS, even if you wrote the same thing here in lithofacial and it's shale in caps lock in one side and shale without caps lock in the other side, it will show as different values at different lithofacials on ArcGIS. So this is what you should do for as many as you have here. You do everything like this. Then when you're done, you save. You go to save as. Go to save as. Why is it looting? Okay. Go to save as. Save it somewhere that you've been working with. Let's save in Ekene. Save it somewhere you've been working with, and then save it in CSV. ms.csv, and you're good to go. Okay, this. Yes. So now I guess you are able to do that yourself. So this is mine here, sample. This is mine. Let me show you. So this is mine. On this on this point I had 4 shales, 4 pyroclastics. Notice how all the pyroclastics are spelled exactly the same with the same caps lock starting it. Not all caps, not half caps, just cap lock starting it, which is kind of proper here. So you have to be specific when doing this. They have to be the same exact thing if they're the same lithology. If I had written one as pyroclastics, Arcgis would see it as a different lithology totally. So for my strike, I think I used the lower strikes in this one. This is my deep directions, and this is deep amounts. Latitude DD, longitude DD. The DD is degree decimal now, so hence you see the decimal. In outcrop here, we use the name / the number, so shale 1, shale 2, shale 3, shale 4, etc. here. So now to import this into Arcgis, you open your Arcgis and let's go there, let's show you. So normally it would have opened the old tutorial one I was working, but that was like a year ago, so it's not even on this laptop. So yeah, I'd expect that you're still working on the same workspace you've been on. So you should have, under your layers, you should have your drainage, you should have drainage, accessibility, settlement, and contour. Yeah, you should have those. So now what you want to do is add data, add XY data, and go to where you save them. Mine is in the Kenya. Okay, Kenya here. So sample CSV, add data. Here you don't need the Z file because there's no altitude file here. So I'm working with MENA because that's what we use in Nigeria. I must have said that before. So you okay this. So these are all the outcrops. There were 8 here. So 1, 2, 3, 4, 5, 6. Complete 8. I don't know why this one is so far away. Must have been a mistake from the author of, or the person that gave me the details here. So it's far off. I might just disregard that. So what you want to do next is you right click here, because this data now we need to convert this to an Arcgis editable data. So you click data, export data. So yeah, you might want to write the name of this so you don't misplace them. So here we're trying to get your lithofasces, so let's call it lithofasces. It doesn't necessarily have to be in caps lock though. Do you want to add the exported data as map? Yes, please. So you see they're on the same exact place, so you can just always off this sample. See, they're the same exact place, and in Arcgis the one on top shows instead of the one under, so that's why this covered. So we have this, your outcrops. What you want to do next is enter property, because we need to differentiate these outcrops. We want someone to look at your map once and be able to know that yeah, these are different types of rocks, these are different lithologies. So you come to symbology, you go to categories, our field value, outcrop. No, we want, because the difference we're looking at now is lithofasces. Remember, we have shale and pyroclastic here, so we want lithofasces to be the differentiating matter. We don't want to see all other values. So add our value. See, pyroclastic 4, shale 4. If we had written capital letter shales, like all caps, after using this first letter cap, you will still have a third one here that would have said capital all caps shale, because Arcgis doesn't care that you know that they're the same. As long as you don't type it the same exact way, they don't care. It's different to them. So yeah, this is the level we're at now. So yeah, you would want to, like I said, you want someone to look at your map and know that these are lithologies. So what I do is we make it obvious. So here we're editing symbol because there's no symbol for shale. Okay, let me show you. Let's start shale. See, the symbol for shell is so lame. You wouldn't even know that this is shell, so we make our own symbol. Edit symbol. Edit symbol, you click marks, click halo, make this 10. Click symbol again. Here now you can search for shell and you would like what you see. So you see, shell. I still go ahead. At this point, you can play on it, make your symbol how you think is nice. I still go ahead to edit this one more and reduce separation so that it's a bit darker. So we have the okay this, okay this, you okay this. Why is it not showing? My just started hanging. Yeah, so this is what I expect to see. What I expect to see here. So yeah, this is what like I said, this is what you see. Then you can still remove this midpoint. See that circle in the middle? I don't like seeing it. So you come here and click one, at least it's less visible now. So what you want to do now is same thing again for pyroclastics. We're editing symbol. We're putting marks, hello, 10, click symbol. So you can try pyroclastics. I'm pretty sure it's not there. In fact, it's not there. Pyroclastics is not there, but this is where you can get, like I said, play with it. Choose what you like. Let's use igneous. Let me stand E. So yeah, I mostly use one of these. Just I think I like this. So yeah. I don't know if this will even come out clear, but yeah, let's work with this. So this is what we have now. Apply. See how it's now differentiable. You don't even need to be a geologist to know that these are two different things, yeah? So you okay this. And we're done with stage one. We've delineated our outcrops. What's next is to put our dips and strikes. And to know which ones have dip and strike. Of course, pyroclastics, they don't. So here, majorly the shell. So what you want to do is export this again. Yeah, again. Export data. Let's call this bed altitude. It's a file name, so you can't use space, hence the underscore. Export here. So here is our bed altitude. It's not showing because I've not toggled it on. So now that it's on, you see it's in the middle. Yeah, you see it's in the middle. So our bed altitude now basically dip and strike. So what we're going to do now is edit this. Edit feature, start editing. Why are we editing it here? We're editing because not all of them have the dip and strike values. So we want to work with only those that do. I don't know why my app is lagging today. So expect this a lot. Continue. So you open the attribute table. Mine shows here, yours should have come out this way. So let me bring it out here. So we want to remove all this null, all that has null in strike value, meaning they don't have strike. So this is this. We want them to go. And that's what we do. So they're off. Now we have everything we need to start working on dip and strike values. So log this here. At this point here, you can off your editor, stop editing, save editing. Right click on this, properties, change the symbol. Here you start strike. I've made my strike value, but I'm showing you, I've made my strike symbol, but I need to show you how to do this. So you start strike, come down to geology 2K, 24K, click this. So it's visible. I made mine 60. You can try other numbers until you get one that you like. I like 60. So you click OK. Click advance, click rotation, geographic, put this as deep direction. So normally what this is supposed to mean is that your deep direction rotation is what would direct the attitude, the bed attitude symbol. But it's not quite that easy on Arcgis here. Well, I'll show you how to work on it. Life hacks and how. Okay, so you okay this. You okay this. You see the bed attitudes have started showing, but they are definitely pointing in the wrong direction. Well, I'm almost sure of that. So the deep directions 30, 25. So all of them are supposed to be in the northeast. But from what we're seeing here, they are all dipping the other way. So we're supposed to work on this now. So now that we've agreed that this is pointing in the wrong direction, what you want to do is correct them. Yeah. So yeah, let's edit again. Start editing. Okay. So this. So our dip is supposed to be dipping in direction of 30 degrees. But from what I'm seeing here, it's dipping around like 120. It went the other way of the quadrant. You know how 120, you know, yeah, 120 is equals to 90 plus plus 30. I think that's what happened here. So instead of it to dip to 30, it's dipping totally away. It's adding the 90 to 30. So we'll have to work around doing this to get it to fix back. So I noticed an error in the data I was using. The deep direction, what was recorded as deep direction was the lower strike. Sorry, the northern strike. So I've corrected it now. This is the normal deep directions. You can check that the deep direction should be 90 higher or lower than your strike. So this is the correct one now. So we can work on this. But even after correcting, you see that this does not align. This is dipping towards the southwest, and the dip of 120 should be somewhere southeast here. Yeah, southeast. So it's still not correct. So we still need to work on that here. The reading is correct, but what it shows on the arc map is not yet correct. So we still need to work on this. So what I was trying to explain before I realized that the readings were wrong. So here we have 120 here, and 120, the nearest quadrant to 120 is 90. So you know how 120 is 90 plus 30. Instead of doing this addition, to get the symbol to fit, we do subtraction. So 90 minus 30, we have 60 here. So I correct this to 60. This is it here. So watch what happens. You see, as I put it to 60, it's now dipping in the 120 direction. Let's try with another one. This guy, 115 is the correct reading, but for Arcgis to work with it, we have to convert this. So 115 is 90 plus 25. So we do 90 minus 25, which should give us 65 here. Yeah, that's it. So 65. Watch it turn. This is now dipping in the southeast, which is what it should be. So quickly we just do the same thing for others. This should be 67, I think. Not calculating it specifically again. So watch them all dip in the right direction because I did that. So what we do, just to remind, what I did is the nearest quadrant minus, instead of plus that it was initially, I did minus to get it to fit. It might not work that way in every situation, so you can just try a couple of numbers that's near it to see what direction is moving and then work with it from that way. You get? You should. So yeah, we're done with that. So I close this. I stop my editing. Save this. So something else you want to know is that your bed attitude should actually be on the exact place where you took it. Why the representation can come behind it. So if you click this on, you see they are on each other and it's crowded. So what you want to do is edit this. Start editing. Okay, this. So this one now that's crowding here, you can just click off that so it doesn't move together. So you move this up a bit. This is out of the way now. You move this up a bit. You can see the better. Move this a bit this way. Yeah, you get the point now. So you move this way too. I went too far. So I'm ignoring this guy, but let me just work with it. Move this upwards. So with that, you've done your you're set. You're good to go for your outcrop map here. And the other thing here is to put the deep amount that you can do using the text figure here, res text. You can do that using text, but before that, you want to on this label. Click label. See, they're all labeled now. If that's not clear enough for you, you can always go to property and change the labeling, and usually make it bigger. Usually make it bigger, say like 11 bold, so it's more visible now. It's more visible, yeah. So you can always add using insert here, add text. Say if it's just dipping 66, sorry, you can just put 6 here. But I'd rather you don't do it yet, because when you put it in this view, which is the view from where you export it, the 6 is likely to shift. So what I do is I leave it till I'm done with my map. Till I'm totally done with my map, then put it. So this goes. So yeah, there you have it. Basically, this is what an outcrop map should look like. This one is a bit crowded. If it's a lot crowded, let me see. Okay, this one is a lot crowded. I told you I'm going to ignore the bottom one because it's too far off. So yeah, we have something like this now. See how there's still space for you to move this guy. So editor. I think I moved them too far because of the resolution I was using. So yeah, you have this now. So what you want to do next is make a geologic map that relies on informations. But in this case, these are pyroclastics, so they are intrusive and you might not have a lot doing here. But okay, let me show you. If this were, say, if this were sandstone and they had deep, say they were deep in this way. Or let me just do something and show you. So what I want to show you here is like the next step. Although I think I will stop this video here and start that in the next video. So copy this, open Paint. I like to try out my stuff on Paint before I do it on Arcgis. So these are intrusive, so they don't really go far. So let's just make a circle. Say we make a circle around this. This is an intrusive, so we'll make a circle around this. These two are very close, so we can join them. Since the remaining parts are shale, and let's say we like shale to be gray, on here I can just use this fill color and fill this. So everywhere that is not in this circle now is shale. That's what this map is showing geologically. You get? So these parts are specifically intrusives. This is intrusives. This right here. This is igneous material, sorry. Right here, the other parts are shale. But if there was some other, say there was sandstone and you had a dip, because I mean the dip and strike is what helps, you know. Say this was dipping, sorry, this was striking this way and dipping this way. The strike goes like this. So you respect the strike when you are drawing, you have to flow like this. So, flow like this. Something like this. Until you get to somewhere around where this one strike is moving, then shale one could go like this. This is your shale striking this way. Shale striking this way. Then let's still say these are intrusives. Shale striking this way. This is an intrusive. So you respect everything here now. We still feel this way. I'm sorry, I didn't quite close this. Let's see if I got it this time. So yeah, what we are saying here is, oh, so this guy always stay open. You have to close all circles, so it's like filling. I mean, the name is fill, so it's like pouring water. If you don't close this, it will flow in. So let's say we fill this, so all the parts in gray is shale. Since we don't have details for here and here, for shale is striking this way, I will still assume this part is shale. Then I told you now, we're assuming this P4 is sandstone. So let's give sandstone its own color. Say this fill. So that's your sandstone. Then, like I said, this part should still be shale since shale is striking that way. So shale. Sorry, wrong color. So shale. So someone that sees this, we know that this was striking this way, and then because of this strike, and I mean shale is striking here, so shale is more of this region. But then again, I'm just digitizing, so you can always make your own geologic inference. I'm just showing you the digitizing and what I feel is possible here. I mean, I could be very wrong. I mean, two different people will always draw two different maps, and you get a geologic map. So this is an idea of how the outcrop map should end. I've showed you how to put the outcrop map, but this is how your geologic map that you make from your outcrop map should be, which will be part of my next video. This is like a snippet. Yeah, it's like a snippet. So yeah, thank you for your time. If this helps you, drop a comment, drop a like, refer to somebody. Have a nice day.